Hello, and let's begin going through the answer key of the application worksheet. Number 1. A rectangular swimming pool is twice as long as it is wide. A small concrete walkway surrounds the pool. The walkway is a constant 2 feet wide and has an area of 196 square feet. Find the dimensions of the pool. I'm going to start by drawing a diagram here. So I'm going to draw my pool, and I know it's rectangular. I'm going to draw my walkway surrounding that. And then I also know the dimensions of, I don't know the dimensions of the pool quite yet, but I know what I could call those. If I call this side here X, I know that the other side is twice as long as it is wide. So I can call that opposite side 2X. Then I know the walkway is 2 feet wide. So I'm just going to label here the walkway. I'm just going to write in a few 2's to remind myself that they're 2 feet wide. And if I want to find the dimensions of the pool, I need to find out what X is. But in order to do that, I'm going to want to use this important 196 square feet info and set just my walkway equal to 196 and then solve for X. So this is a similar problem to something that we have looked at before. So what I need to do is I need to figure out this total side length and this total side length and then subtract the area of the pool so I can just find the walkway surrounding the pool and then set that equal to 196. So let's figure out this side down here first. I know that, I'm going to change colors here. I know that this here is 2 feet. I know this here is 2x, so I'll add on 2x. And that right there is 2. And now I'm going to combine some like terms, so 2x plus 2 and 2 gives me 2x plus 4. Underline that. Now let's look at the other side here, and I know this is 2, this is x, and this is 2. So now if I put those together, the like terms, I get x plus 4. Now, I know the dimensions of the walkway and the pool together, so what I'm going to do is, I'm going to get some extra room here, is I'm going to go ahead and find the area of the walkway and the pool. So I'm going to multiply length by width and take 2x plus 4 times x plus 4. And then at the same time, I'm going to subtract then the area of the pool, which is 2x times x. I'm going to do a little bit of math here. If I FOIL 2x plus 4 and x plus 4, I'm going to get 2x squared plus 8x plus 4x plus 16, and then subtract 2x times x, which is 2x squared. Now, I am going to set that equal to 196 because I know that what I had just found out, that expression, that's just the area of the walkway, right? Because I took my walkway right here, area of my walkway, and subtracted area of the pool. So I could even write above pool, and this is walkway plus pool. And that will leave me then with which will leave me with the walkway, which we also know is 196 square feet. So now let's combine some like terms that we can. So 8x and 4x gives me 12x. My 2x squareds actually cancel out. So 12x plus 16 equals 196. Subtract 16 from both sides. And I get 12x equals 180. And then I want to go ahead and divide by 12 and get x equals 15. So I know that x equals 15, so if I go back up to my drawing in the question, oops, and I'm now right, you can see I'm over the area that I want. And the question says, find the dimensions of the pool. So if we know one of the sides is x and the other is 2x, then the dimensions of my pool will be 15, and the other side, which was 2x, is 30. So this pool is 15 by 30 feet. Number 2, the side of a cube is represented by x plus 1. Find, in terms of x, the volume of the cube. So I'm going to first draw my cube. Here I go, I'm going to draw a cube, something like this, so I can get a visual going. And I got my cube. Now I know that each side is x plus 1, and I want to find the volume. So that means I want to figure out length times width times height. So I have x plus 1 times x plus 1 times x plus 1, or essentially x plus 1 cubed. So I'm going to go ahead and write out what this would look like. X plus 1 times x plus 1 times x plus 1. And we know that we have a couple special products here. This is a square of a sum, so I'm just going to start by multiplying 2 together. And so with the special product rule, square of a sum, I'm going to square my first term and get x squared. Going to, for my middle term, take my first term x times my last term 1 times 2 to give me 2x, and then square my last term, which is 1, but 1 squared is just 1. So I get now a trinomial, but I still have to multiply that now by x plus 1. So I'm going to go ahead and use the box method here. I'm going to make a 2 by 3 here, like this, and that lines up nicely. And I have x plus 1, and here I have x squared plus 2x plus 1. And x times x squared is x cubed, 2x times x is 2x squared, 1 times x is x squared there, 2x, and 1. And I do have some like terms here, and I get x cubed plus 3x squared plus 3x, if I'm combining some of these like terms here, plus 1, and then I'll label this units cubed because I did find volume. And now I am done. Number 3, let an integer be represented by x. Find, in terms of x, the product of 3 consecutive integers starting with x. Well, I know if I start with x, say that's any integer, I know the next highest integer will be x plus 1, and after that will be x plus 2. And those will be consecutive integers for any integer I decide to plug in for x. Now I just need to go ahead and multiply them together. So I'm going to look at the first two, and I'm going to multiply x times x plus 1 and get x squared plus x. Now I still have to multiply that by x plus 2, so I could use the box method or FOIL, whichever one. I'm going to go ahead and use FOIL right now. And I'm going to take x squared and multiply that by x and get x cubed, then x squared times 2 for 2x squared. X times x gives me x squared, and x times 2 gives me 2x. I'm going to combine some like terms right here, and I'm going to get x cubed plus 3x squared plus 2x. And that would be my solution. I'm done with that one. Number 4, write a variable expression for the area of a square whose side is x plus 8. So I'm going to go ahead and draw a square. And I know each side of a square is the same. So if I want to now find area, length times width, I know that x plus 8 is the dimensions for both the length and width. So I'm going to go ahead and multiply those together. X plus 8 times x plus 8. And I could FOIL, I could use the box method, or I could use the special products rule that we learned about, which is a lot simpler and can do that in my head. I don't have to show as much work. So I'm going to go ahead and do that right now. And I know with the special products rule that I want to square my first term, which is x, and get x squared. For my middle term, take the product of my first term times my last term times 2. So 8 times x times 2 will give me 16x. And for my last term, I want to square my last term, which is 8, and get 64. And then since I found area, I'm going to label this units squared. Number 5, the length of a rectangular window is 5 feet more than its width, W. The area of the window is 36 square feet. Write an equation to represent the area of the window. Okay, so I'm going to draw my window here. This is going to be an orange window. And I'm going to label my dimensions. So if I know my one side is W, the other side is 5 feet more. So that's going to be W plus 5. Now I know that that area of that window is 36 square feet. So what I can do is I can take my length times width and set that equal to 36. So W times W plus 5 equals 36. And then I can simplify this out a bit and get W squared plus 5W equals 36. And I even want to simplify it more, so I could rewrite that by moving the 36 over and just setting my equation equal to 0. So I would subtract the 36 then to move it over. And either one of these two will be our solutions. Now, didn't ask us to solve the equation, just write an equation, because we don't quite know how to solve an equation like that, but that's what we are going to solve, be able to factor in Chapter 8. So be looking forward to that. Number 6, find an expression for the area of a triangle with base length 3x minus 4 and the height is x plus 1. So I'm going to draw my triangle here. Triangle. I know my height here, if I draw in height, that is x plus 1. And I know my base is 3x minus 4. Now if you can recall, formula for area of a triangle is 1/2 my base times my height. So my area here, if I plug in the information I know, area equals 1/2 my base times my height. And it's okay that I switch the order because order doesn't necessarily matter here in this formula. And now I'm going to go ahead and do some math here. So I'm going to FOIL x plus 1 right over here times 3x minus 4. And when I FOIL that, I get 3x squared minus 4x plus 3x minus 4. Combine like terms and I get 3x squared minus x minus 4. So now that I'm going to use right up here. If I continue with my formula, area now equals 1/2 of 3x squared minus x minus 4. And now I'm going to distribute that 1/2 to every term inside the parentheses and use the distributive property. And so the area equals 1/2 times 3 is 3/2, and then attach my x squared. 1/2 of negative x, negative 1x, is negative 1/2 x. And 1/2 of negative 4 is negative 2, so minus 2 there at the end. And then because this is area, I will label units squared. And that's the area of this triangle. Number 7, suppose you start with an 8-inch square piece of cardboard. Squares with side length x are cut out of the corners and the sides are folded up to make a box. Write a polynomial in standard form for the volume of the box. So let's start by making a picture. It might be helpful to see what this would look like. So if I draw a box here, like this, I know that I start with 8 inches, so 8's on all the sides of this box. and I know that I'm cutting out corners here in each corner, little squares that are the same length, and those are side length x. So each of those side lengths are x. I'm going to fill those in. Okay, now what I want to do is I need to figure out this volume. So essentially, when I find the volume, I need to figure out the length, the width, and the height. So, and this might be easier to see if you use an actual physical box to help you visualize what's happening here. But think about the corners are going to be folded up. So, you know, these corners right here eventually would be folded up. So I know that the height is going to be x. That's actually the height. So if you can visually think about that box folding upward. And again, Ms. Roddy will probably go through this problem, that's me, during class to help you visualize this even more. But now we know the height is x. That's how height, you know, that's the height. We need to figure out then the length and the width. So this essentially, you know, the sides are going to be the length and the width, except it's not going to be 8 because you're cutting out those corners that I have colored or drawn in red. Those are cut out. So essentially what I need to figure out is I need to figure out this distance to this distance without those x's that are cut out. So if I know this entire distance down here is 8, but I'm cutting out this corner here with length x and this corner here with length x, that is 8 minus 2x for the side length. Same thing with this side over here. This really starts with being 8 inches, but I'm going to subtract the x on both sides that I have arrows drawn at. And so when I find this distance, you know, from there to there, that also is going to be 8 minus 2x because it is a square. So essentially think about the length and the width being the same, but your height's different when you find the volume. So I know that my width, I'll make a little arrow here, is 8 minus 2x because I cut out 2 corners on each side. And then my length is also 8 minus 2x. And to find volume, I need to multiply 8 minus 2x by 8 minus 2x by x. So let's go ahead and I'm going to multiply 8 minus 2x by 8 minus 2x. So 8 minus 2x by 8 minus 2x. This is a special product rule. So I am going to first square my first term and get 64, because 8 squared is 64. For my middle term, I'm going to take 8 times my last term, negative 2x, times negative 2, and get negative 32 x squared. And then, or excuse me, negative 32x, not x squared. So I need to erase that. Here we go. Not x squared. Not x squared. Okay. And then the last term, negative 2x squared, is 4x squared. Now, I've just figured out what 8 minus 2x times 8 minus 2x is, so the length times the width, but I have not yet multiplied by the height, which is x. And this is where I got the negative 32x squared. I was trying to multiply a little bit more in my head. But now if I distribute this x to each term here, I get 64x minus 32x squared plus 4x cubed. And then the directions also stated to write the answer in standard form. So I'm going to flip a couple things because I know standard form is highest degree to lowest degree. And I get 4x cubed minus 32x squared plus 64x units cubed, because I found volume of that box. Number 8. The diagram shows the wooden floor of a living room with a rectangular rug in the middle of the room. Find the area of the wooden floor bordering the carpet. So this is a similar problem to ones that we have done where we have, a rectangle or something that's inside of another rectangle, and I only want to figure out the outer rectangle in the outer region. So I need to find the area of the outer region, but not the inner region. So I'm going to start by figuring out, length times width of my outer diagram, right? The wooden floor. So I'm going to take length, 5x plus 3, multiply it by width, 2x. But now I only want that wooden floor, so I'm going to subtract that rectangular rug that's inside that. So I'm going to subtract 3x minus 1 times x, so subtract that rug's area. And then I'm going to just do a little bit of math here and take 5x times 2x and get 10x squared, and take 3 times 2x and get 6x, and now subtract what I get over here. So if I multiply that together, 3x times x is 3x squared, negative 1 times x is negative x. Now I'm going to go ahead and combine some like terms. So I have, we'll rewrite this, 10x squared plus 6x minus 3x squared, and then if I, have double negative, it's really plus x. And then combine some like terms here. So 10x squared minus 3x squared is 7x squared. And then if I combine my 6x plus x would be plus 7x. And I have no more like terms, but I will label my units and write units squared. And now I am done. The last problem you have is to make up your own. Good luck.